Hey everyone, and welcome. So, if you're a BTech student slinging code, I bet you've been there. You're hours into a project, your eyes are getting blurry, and you suddenly realize you're writing the exact same chunk of code for the third time. It's such a headache, right? Well, today, we're going to talk about a fundamental concept that transforms that copy-paste nightmare into something really elegant. We're diving into the power of inheritance. Seriously, does this feel familiar? You're building out a program, maybe for a class assignment, and you find yourself just highlighting a block of code, hitting copy, and then paste. And you just know, deep down, there has to be a smarter way to do this. And you're absolutely right. The solution is one of the pillars of object-oriented programming, and trust me, it's way more intuitive than it sounds. Okay, let's look at this classic coding conundrum. On the left, we've got a class for a car. On the right, a class for a truck. See what's happening here? They both have a make, a model, a year. They both have ways to start engine and stop engine. This is duplicated code, plain and simple. Sure, it'll run, but it's super inefficient. And just think about the maintenance. If you find a bug in start engine, you gotta remember to fix it in two different places. That's a recipe for disaster. So, how do we clean up this mess? The answer isn't some crazy complex algorithm you have to memorize. Nope. It's an idea you already get just from looking at the world around you. It's all about finding what things have in common. And here it is, the big aha moment. What do a car, a truck, and a bus all share? They are all types of vehicles. A car is a vehicle. A truck is a vehicle. That little phrase, that relationship is the absolute key. Once you start seeing your code this way, everything changes. And this whole concept has a name, inheritance. It works pretty much exactly like it sounds. We create a general parent class, in our example, vehicle, that holds all the common stuff. Then we can create more specific child classes like car and truck that automatically get or inherit all those shared things from their parent. So what does this actually look like in code? Well, you have your parent class, which programmers also call a superclass. That's our vehicle. It defines all the common things like make and model. Then you have the child class or subclass. That's our car. And with one simple keyword, like extends, we're basically telling the car class, hey, you get everything that vehicle has, plus you can add your own unique stuff. This is where the magic really kicks in. The child class just reuses everything from the parent automatically. Think about that. You write the start engine method just one time inside the vehicle class, and bam, the car class gets it. The truck class gets it. If you make a bus class or a motorcycle class, they all get it. For free. No more copy-pasting. Let's just take a moment to appreciate this glow up. On the left, the before, two separate, clunky classes with a bunch of repeated code. It's a mess and a headache to manage. And on the right, the after, clean, logical, and so much smarter. One parent, vehicle, holds all the shared code, and the children just inherit it. This is a massive win for keeping your code organized and sane. Okay, so this whole parent-child idea is pretty cool, but it doesn't stop there. It can get even more interesting, kind of like building out a whole family tree for your code. So let's explore the different types of inheritance you'll run into. This is called multi-level inheritance. And honestly, it works just like generations in a family. In a lot of programming languages, you have this base object class. You can think of it as the great-grandparent of everything. Our vehicle class can inherit from that. Then our car class inherits from vehicle. See the chain? Each level gets more specific, but it inherits all the traits from every generation above. So broadly speaking, you'll see two main flavors of this. First, and by far the most common, is single inheritance. That's what we've been looking at. One child inherits from one parent. Simple, clean, it's used everywhere. Then you have multiple inheritance. This is where a child class can have more than one parent. Imagine creating an amphibious vehicle. It kind of needs to be a car and a boat, right? It's a really powerful idea, but it can get complicated fast, which is why some languages don't even allow it directly. All right, let's bring this all home. We've talked about what inheritance is, how it works, all the different types, but why does this actually matter to you, the student who's just trying to get their project done? What's the real takeaway? Well, it really comes down to three huge wins. First, code reusability. I mean, you literally write less code. You write the common stuff once, and you use it everywhere. Second, your code becomes way easier to understand. It creates this natural, logical structure that just makes sense. And third, and this is a big one, maintenance becomes a dream.
Remember that bug in the engine? Now you fix it in one place, the vehicle class, and poof, it's fixed for every single child class instantly. That is an absolute lifesaver.
So inheritance is fantastic for sharing behavior that's the same. But this leads to a really fascinating new question. What if a child class needs to do something that the parent does, but in its own unique way? I mean, a sports car and a giant truck both move, but they do it very, very differently, right? How do you handle that? Well, that, my friends, is a powerful concept called polymorphism, and it's a story for our next explainer.